Today we're going to talk about solving radicals. You'll notice your assignment has a couple of additional things that we need to know, one of which, of course, is factoring. We've got to know how to factoring going into rationals. The method of your factoring is up to you. We won't be checking these, we won't be reviewing these, but you need to be able to factor. Remember, we can also factor by graphing and seeing where it crosses the x-axis. So when I graph an equation and I see that it crosses, let's say it crosses at -2 and +4, let's remember that -2 crossing comes from the factor x plus 2, and the +4 crossing comes from the factor x minus 4. All right, so keep that in mind. You may want to use your graphing calculator to factor, or we can factor by hand, and that's what we're going to look at first. So when we're asked to factor this trinomial right here, remember what we're looking to do is find the factors of 24 that can become 2. The middle number is what we're shooting for using the outside number. So the factors of 24, of course, are 1 and 24, 2 and 12, 3 and 8, 4 and 6. So of these pairs, the only one that can get us to a +2 is the combination of 4 and 6. And it works when the 4 is negative and the 6 is positive. So we're going to break that factor down as x minus 4 times x plus 6. Now, you know several other ways of factoring as well. Like I said, graphing is one way of doing it, but we just need to know how to factor and make sure we get down this trinomial to the binomials. And these are the examples on your Delta Math. This should be your first one. Next thing I want to talk about as we work through these rationals is just the nature of these rational equations. What I mean by that is what they look like. What a rational equation is when we have a variable in the denominator. It doesn't matter just having a variable and being division. The variable has to be in the denominator, just like we see here. Now, the way a rational works is the larger the denominator gets, the smaller the number is going to get. So in this case, all we're doing is just looking at the nature of it. And in this case, it's telling us to find the equation if x were -1. So we're just going to replace our x with -1. This would give us 34 divided by 2, which of course is 17. Got just a couple of those on your Delta Math. Again, I just want you to get accustomed to the nature of these things. One thing I do want to discuss before we move on is we mathematically cannot divide by 0. We cannot have a number divided by 0. It even spells out when you look at it, no, don't do this. So in this case, we won't see this in our homework today, but we will tomorrow. We need to set up excluded values or restrictions on the domain. And what it states is we cannot be equal to 0. So in this particular one, what we learned is that x cannot be equal to -3, because if x is equal to -3, my denominator is 0, which cannot happen. And again, we'll elaborate on that more tomorrow. Now we get into actually factoring these things. So, and simplifying, excuse me. One phrase you need to keep in mind, you might want to write this one down as well. If you can't factor it out, you can't cancel it out. So keep that in mind as you go through. If I can't factor it, I can't cancel it. So in this particular question, and what I want to do is find a GCF of the numerator and the denominator. Keeping in mind, I want to look for something that might cancel. So when I look at the top, I see that they both do have an x. So when I factor this x, I'm going to leave a parentheses for what's left after the x is gone. So when I factor an x from x squared, I have an x. When I factor an x from 5x, I have a 5. So my numerator factored out is that My denominator, you could write it as a prime factorization, which is 2 times x times x. I don't need to see it that way. You're welcome to do it another way. I like to just cancel these in place. So if I have 2x squared, I now have and factored out, like we talked about. I did factor it out, an x, so I can cancel out 1x from the top and 1x from the bottom, leaving me with x plus 5 over 2x. Now I want to talk about something on this equation. That's done, by the way, but I see this a lot of times. One of the most common mistakes that I see is people trying to go further than this. We cannot cancel out an x at this point. A lot of people are going to want to come in here and cancel these x's out like that, but the problem with that is our little rule should tell us otherwise. Can I factor out an x from x and 5? No, the answer is no, I cannot factor. So if I cannot factor out an x, I cannot cancel out an x. So keep that in mind. If you're not sure on something you can do, keep that little topic in mind. So as we look at this one, we need to keep in mind we're factoring. We need to factor the numerator and the denominator. Anytime we see two terms, we should immediately think that this is going to be the difference of squares. We could graph these and see where they cross as well. And if you do that, what you're going to learn is it crosses at positive 2, which comes from the factor x minus 2. And it crosses at negative 2, which comes from the factor x plus 2. So this is what we end up with. Now our denominator, we need to factor it as well. We need the factors of 10. Well, there's only 2 of those, 1 times 10 and 2 times 5. But we need the factors of 10 that can become positive 3. And we can get a positive 3 if our 2 is negative and our 5 is positive. So those are the factors that are going to work here. We will have x plus 5 and x minus 2. At this point, and we'll spend some more time on this tomorrow, but we need to have it in the back of our mind. Before we cancel, we need to state excluded values. Well, our denominators here cannot equal 0, either one of them. So we need to make sure that x plus 5 does not equal 0, and also that x minus 2 does not equal 0. So our excluded values here are going to be negative 5, x cannot be negative 5, and x cannot be positive 2. And those are excluded values. But we won't be asked for excluded values today. What we will mainly be dealing with is simplifying. Now, anytime we have a number divided by itself, even if that number is a binomial, trinomial, whatever the case may be, those numbers cancel. They technically become 1. Any number divided by itself is 1. But for all intents and purposes, we know that they are going to cancel. So the x minus 2 from the top and the bottom are going to cancel one another out. And it leaves me with x plus 2 over x plus 5. I drop the parentheses. You can leave them. You can drop them. It doesn't matter. It should be the same either way. Another way you can check your answer on these is if you go back to your original question and put it in the y1 in your calculator, and then you put what you think the result is in the y2, you should get identical tables, and you should get identical graphs as well. The only exception is you might get an error reading in the table, and that's okay. But this is another way that you can check your answers, and I suggest you do that as well. All right, you guys can start on your Delta math. This should follow the examples. I think you have 7 of these and 3 of the others. Have a good day.